Something may be alive right now, breathing beneath the red dust of a world that lost its oceans 3 billion years ago. Not on the surface. The surface of Mars is a killing field. Radiation pours down unfiltered because Mars long ago lost the magnetic shield that would have blocked it. The air is thin enough to boil your blood and cold enough to freeze it in the same afternoon. Nothing we know could last an hour up there. But go down a few meters, maybe a few hundred, into the rock, into the frozen pockets of ancient water, into the dark. And the rules change. The temperature steadies. The radiation fades. The savage swings of a Martian day, from scorching noon to a night colder than anything on Earth, flatten out into something gentle and constant. And there may be liquid water tucked into the pores of the stone, exactly where certain instruments have begun to notice things they cannot fully explain. Puffs of gas that come and go with the seasons. Chemistry that looks from a distance like the chemistry of something eating and breathing. Sit with that. Not proof, not a headline you can trust yet, but a genuine, open, unresolved question hanging over the fourth rock from the Sunday. And the strange part, the part almost nobody sees clearly, is this. The reason we cannot answer it is not really about Mars at all. It is about how hard it is to know anything at all across that much distance and that much time. Most people assume that if life were down there, we would simply know by now that a robot would have found it or a photograph would have shown it. That is the belief. The truth is stranger and slower. We are not waiting for discovery. We are waiting to become certain, and certainty across tens of millions of miles is the rarest thing there is. That gap between the easy belief and the difficult truth is where this whole story lives. So let us walk into it slowly and carefully, together. So before we get anywhere near an answer, we have to be honest about a harder question. How do we know anything about a place no human has ever stood? You have never touched Mars, neither have I. Not one person has walked its surface, scooped its soil, held its rock in a bare hand. Everything we believe about that world arrives here as a thin trickle of information. Light, radio signals, a handful of numbers beamed across tens of millions of miles. And that gap matters because it shapes what we are even allowed to claim. Let me put the distance in real terms. When Mars is close, it sits about 34 million miles away. When it swings far, more than 250 million. Light, the fastest thing there is, takes between 3 and 22 minutes to cross that gap. Think about driving that. At highway speed, without stopping, it would take you more than 60 years just to reach Mars at its nearest. 60 years of driving, day and night, never sleeping, and you would still only be arriving on the good day, the close day. On the far day, you would be dead of old age twice over before you got there. And here's the thing worth holding on to. The speed of light is not just fast. It is a limit, a hard ceiling on how quickly any information can travel anywhere in the universe. Nothing you have ever seen or measured has broken it. It is not a technology problem we will one day solve with a better engine. It is written into the structure of reality, into space-time itself, the woven fabric of space and time that everything moves through. So when a rover on Mars sees something surprising, we do not find out for minutes. We are always looking at a slightly older version of that world, reading a letter that was already sent. If Mars did something dramatic at this exact second, the news would still be crossing the dark and would not reach us until well after it happened. Now think about what that means for a claim as enormous as life. We cannot pop over for a look. We send a machine, and the machine sends numbers. And from those numbers we reason. Everything hangs on the reasoning. This is the part I find genuinely thrilling and a little humbling. Almost nothing we say about Mars comes from seeing. It comes from inference, from building a chain of logic where each link can be checked. Let me show you how one of those links actually works, because it is more elegant than you might expect. A spectrometer splits light into colors, the way a prism does, and the pattern of missing colors tells you which gases are present. Every molecule absorbs light in its own signature way, like a fingerprint made of shadows. Methane leaves one pattern, water vapor leaves another, carbon dioxide another still. When light passes through a gas, the gas quietly steals specific colors out of that light, always the same colors for the same molecule, never varying. So the light that reaches your instrument arrives with tiny gaps in it, dark lines where colors should be. And from the exact placement of those gaps, you can name the gas that ate them, even though it sits tens of millions of miles away. You do not have to travel to the gas. The gas announces itself in the light that passes through it. That is not a guess. That is measurable, repeatable, checkable. Send another instrument and it should read the same fingerprint. But it is also indirect. And the further you are from the thing itself, the more careful the chain has to be. Here is a rule I keep coming back to. In this kind of science, authority never comes from someone saying so. It comes from prediction and measurement. From saying, if this is true, then that instrument should read this number, and then the number shows up. That is the whole game, not confidence, not reputation. Prediction, then measurement, then honest accounting of what is left. And that accounting is brutal in the best way. Every time you find a signal, you are obligated to hunt for the dull explanation before you allow yourself the exciting one. Think of it as a court where the boring theory is presumed innocent and the thrilling one has to prove its case beyond reasonable doubt. Because on a world you cannot visit, the boring theory is almost never truly ruled out, only made less likely. So when you hear that something might be alive beneath Mars, do not reach for belief or dismissal. Reach for the chain. Ask what was measured, what it could mean, and what else it could mean instead. Because in a place we have never touched, the second most likely explanation is always waiting quietly in the room. And with that in mind, we can finally look at what has actually been found. Picture a single wisp of gas and let it tell you a story. The gas is methane. On Earth, methane is almost a signature of life. Cows make it. Swamps make it. Rice paddies make it. Bacteria deep in rock make it, feeding on stone and water in total darkness, needing no sunlight at all. It is a simple molecule, 1 carbon and 4 hydrogens, and it is fragile in an important way. In the atmosphere of Mars, sunlight and chemistry break methane apart. Ultraviolet light knocks it to pieces. It does not last. Give it a few hundred years, at most, and any methane there is gone. Compare that to the age of Mars. Billions of years and a few centuries is nothing. It is the blink of a cosmic eye. So here is the thought experiment. Suppose you detect methane in the Martian air. What must be true? Something has to be making it, right now, or at least recently, in geological terms. Because if it were ancient, it would already have been destroyed. A puff of methane is not a fossil. It is a fresh signal. Something is releasing it into the air on a time scale that is, cosmically speaking, this morning. Let me make that concrete. Imagine you walk into a room and smell fresh coffee. You do not need to see the cup. You know with certainty that coffee was brewed recently because the smell fades fast. Methane on Mars is the fresh coffee smell. Its very presence dates itself, and instruments on the surface did detect it. A rover sniffed the air and found methane in small amounts, rising and falling, around half a part per billion on a quiet day, spiking several times higher on others. Now, half a part per billion sounds like nothing, and in raw amount, it nearly is. But remember, this is a gas that should not be there at all, being actively destroyed, and yet the instrument keeps finding it again and again over years, higher in some seasons, lower in others, almost breathing. The measurements followed a rhythm, warmer months bringing more, colder months less, as if something were being released when the ground warmed and sealed away when it cooled. That seasonal rhythm is the detail that makes the hair on my arm stand up. Random chemistry does not usually keep a calendar. A pattern that returns with the seasons hints at a process tied to temperature, to the freezing and thawing of something in the ground, to a door that opens when it is warm and shuts when it is cold. Now here comes the turn. Because a satellite orbiting Mars, looking down at the same atmosphere with its own instruments, often saw almost nothing. The rover on the ground smells methane. The orbiter above sees barely a trace, near the limit of what it can even measure. Both cannot be simply right in the obvious way, and that contradiction is not a failure, it is a clue. It suggests the methane is not spread evenly through the air. It seeps out locally, near the ground, maybe from cracks in the rock, and then something scrubs it away before it rises high enough for the orbiter to catch, which means whatever is making it is close to the surface and patchy and tied to specific spots. Think of a room where you smell smoke near the floor, but the ceiling detector stays silent. The smoke is real. It is just staying low and vanishing fast. And that immediately tells you something about where to look. Not up in the sky, down at the ground, at particular cracks and vents, at specific addresses, rather than the whole planet. Now, does methane mean life? No. And this is where the honest reasoning saves us from ourselves. Rock and water can make methane with no life involved at all. There is a process where certain iron-rich minerals react with water, a slow chemical marriage, and it releases methane over ages with no living thing anywhere near. That reaction has a name and a well-understood chemistry, and it happens on Earth in places with no biology at all, deep in the crust where water meets the right rock. Volcanic leftovers can too. Meteorites falling and cooking in sunlight can nudge the numbers. Even dust storms grinding minerals together have been proposed. So methane is a question, not an answer. But look at what the question implies. Either there is active geology beneath Mars, water reacting with warm rock deep down, which is fascinating on its own, because it would mean Mars is not a dead stone, but a planet still quietly, chemically alive. Or there is something eating and excreting in the dark. And notice what both of those have in common. Both require liquid water below the surface. Both point downward, away from the dead surface, into the layer where the rules are gentler. The gas is just the smoke. The fire, whatever it is underground. And that changes where we look next. Now let me hand you a bucket of Martian soil and ask you to watch what happens. This actually happened, in a sense, decades ago in one of the boldest experiments ever flown. A pair of landers set down on opposite sides of the planet, and each carried a little laboratory. A lander scooped up soil, dropped it into a small chamber, and fed it a nutrient broth. A soup of the kind of molecules that living things love to eat, tagged with a radioactive marker so any released gas could be tracked. Let me be clear about how clever that tagging is. By marking the food with a radioactive label, they made any gas that came out carry a signature straight back to the food. So if gas appeared, they would know it came from something consuming the broth, not from some unrelated reaction. The logic was beautiful and simple. If something in that soil is alive and metabolizing, it will eat the nutrients and breathe out gas. The tagged gas will carry the radioactive marker, so a detector will see it climb. If the soil is just dead chemistry, nothing much should happen. They ran it, and gas came out, a strong, clear signal, rising quickly, exactly the kind of curve a living metabolism would produce. For a moment, it looked like an answer. Sit with how that must have felt. A machine on another planet feeding soil, and the soil breathes back. Not on one lander, on both, thousands of miles apart. Two separate machines, two separate patches of ground, the same startling result. But then came the control, and this is where the reasoning gets sharp. This is that court I mentioned. The boring theory demanding its fair hearing. They took another sample of the same soil and heated it to a temperature that should kill anything alive. Sterilize it, cook it clean, then feed it. If the first signal was life, the cooked sample should stay silent. Life would be dead, and dead things do not eat. And the cooked sample stayed mostly silent, which is exactly what you would expect from biology. The living sample breathes, the sterilized sample does not. That is a textbook result. If you saw only those two curves, you would close the case and call the newspapers. So why is this not settled, celebrated in every textbook as the day we found life? Because a second instrument on the same lander looked for the molecules of life directly, the carbon-based building blocks, the organic compounds any living thing would leave behind, and found essentially none. And that is a brutal contradiction. Metabolism without the ingredients of metabolism. It would be like finding smoke and heat and crackling in a room and no fuel anywhere, no wood, no wax, no wire. A fire with nothing burning. That cannot be right. So one of the two readings must be telling us something other than what it seems. So the field split, and it has stayed split for decades. Some argued the gas came not from life, but from strange reactive chemistry in the soil. Compounds that behave a little like bleach, aggressive salts baked by radiation that would fizz when wetted and go quiet when cooked, mimicking a living response without any life at all. And here is the uncomfortable elegance of it. Such a compound would also fall silent after being heated, not because life had died, but because the reactive chemical had been broken down or driven off by the heat. So the very control that seemed to prove biology could be explained just as well by dead chemistry, years later, other missions found exactly those kinds of aggressive salts in the Martian dirt, which made that lifeless explanation stronger, though not certain. Here is the turn, and it is one of the hardest lessons this whole subject teaches. The same measurement can point at two completely different worlds. A world with microbes in the soil and a world of clever dead chemistry both produce the same reading on that instrument. And you cannot choose between them with confidence, not from that distance, not with those tools. What that ancient experiment really discovered was not life and not its absence. It discovered how deceptive the chemistry of Mars can be, how a lifeless planet can wear a mask that looks alive. And that is not a small thing to learn. It reshaped every mission that came after, which means any future claim has to clear a much higher bar. It is not enough to see something breathe. You have to rule out every clever, non-living way the planet could fake that breath. That is why the next generation of missions no longer just looks for activity. It looks for structure, for specific molecules, for patterns that dead chemistry has no easy way to counterfeit. It looks for the difference between a machine that hums like life and a thing that is actually alive. And that lesson leads straight into the deepest place of all. Go all the way down now into water that has been sealed in darkness for 1 billion years. Radar carried on a spacecraft can, in a way, see beneath the ice, not with light, but with radio waves that pass into the frozen cap at the Martian South Pole and bounce back. The trick is patience and physics. The instrument sends a pulse down. The pulse travels through the ice, and part of it reflects off whatever boundary it hits at the bottom. And the way it bounces tells you what is underneath. Different materials reflect radio waves with different strength. This is not so different from a ship's sonar mapping the seafloor by sound, except here the pulse is radio, and the ocean it crosses is a mile of solid ice. A bright, sharp reflection, brighter than the ice above it, can mean one thing in particular: liquid, not more ice. Water reflects radio waves far more strongly than frozen ground does, so an unusually bright echo from the base of the ice is a flag that says, something down here is wet. Water, held liquid far below freezing by dissolved salts, the way salt keeps roads wet in a hard frost when fresh water would have frozen solid. Salt lowers the freezing point, so a briny pocket can stay liquid at temperatures that would turn pure water to stone. And the radar found bright patches, signals that look, to some readers of the data, like lakes of briny water trapped beneath more than a mile of ice. Sit with that image: cold, salty, black, pressurized water, sealed under the pole, possibly stable for ages, untouched by sunlight since before complex life walked on Earth. A hidden reservoir, older than the fish, older than the trees, older than nearly everything that has ever lived on our own world. Now here is why this matters more than a puff of gas. On Earth, wherever we find liquid water, we find life every time. Let me say that again, because it is the whole hinge of this section. Every single place on Earth where there is liquid water and a scrap of energy, we have found living things. In boiling vents on the deep ocean floor where no sunlight has ever reached, where whole ecosystems feed on chemistry pouring out of the crust. In pockets of brine locked inside Antarctic ice. In rock miles underground. In water that has been isolated for tens of millions of years, we find whole communities of microbes living on nothing but chemistry, living on the energy in the stone itself, breathing minerals instead of air, no sun, no surface, no sky. We have drilled into rock that had been sealed off since before the dinosaurs and found it inhabited. Life on Earth does not actually require a friendly planet. It requires liquid water and a source of energy and time. And Mars, beneath its dead face, may have all three. So run the thought experiment forward. Suppose there really is a lake down there. What would it take for it to be lifeless? You would need a reason for life, either never to have started or to have started and then vanished in the one kind of place where on our own world it never fails to appear. That is not impossible, but notice how the burden has quietly flipped. On the surface, the natural expectation is barren. Down there, in liquid water, the natural expectation, judging by every case we know, tilts the other way. On the surface, life would be the surprise. In the buried lake, the absence of life might be the surprise. But here is the honest turn, the one that keeps this from becoming a fairy tale. We are not sure the water is even there. Other readings of the same radar suggest the bright signal could come from certain clays, ordinary minerals that happen to reflect radio waves strongly, or from layers of frozen material, not liquid at all. Some scientists point out that the pole may simply be too cold, even for salty water at those depths. So cold that you would need an implausible amount of salt or a heat source we have no evidence for. Once again, the same measurement, 2 worlds. A hidden lake or a trick of ice and mineral, and we cannot yet reach down to check. Drilling through a mile of ice on another planet is beyond anything we can do today. We can barely drill deep on our own world without enormous effort. So what we have at the bottom of Mars is the strongest case and the deepest uncertainty at once, the best possible address for life, and no confirmed tenant, a door we can see but cannot open. And when you step back and lay these 3 findings side by side, something quietly extraordinary comes into view. 3 separate clues from 3 different depths, all leaning the same direction. look at what we actually have. A gas in the air that should not last unless something is making it now. A soil experiment that breathed like life and then refused to explain itself. A possible hidden reservoir of liquid water in the one setting where, on Earth, life is simply never absent. Each one alone is inconclusive. Each one has a dull explanation waiting beside the thrilling one. The methane could be rock and water reacting with no life at all. The breathing soil could be bleach like salts. The buried lake could be clay. But watch where all three arrows point. Not at the surface, down. Every single one of them sends you beneath the crust, into the sheltered dark, into the layer where water can stay liquid and radiation cannot reach and temperature holds steady. The methane seeps up from below. The reactive soil chemistry is driven by what the surface conditions do to material stirred up from below. The water, if it is there, is far below. This is what I find genuinely beautiful about the whole picture. Three completely independent lines of evidence, gathered by different machines using different physics, radar and spectroscopy and a chemistry experiment, and they converge on the same hidden place. That convergence is worth more than any one of them alone, because a single clue can be a fluke. A single instrument can be fooled. Any one measurement taken by itself is a coin that might have landed heads by accident, but three coins thrown by different hands in different years for different reasons, all landing the same way, that is no longer easy to wave off. Three, pointing together, gathered decades apart by different teams, form a pattern that is much harder to dismiss. Now here's a question worth stopping on. Why should a planet that looks so dead be so persistently interesting? And now let me widen the lens all the way out, because this is where it stops being only about Mars. Step back to the whole cosmos for a moment. The Big Bang, 13.8 billion years ago, cosmic inflation, stretching the fabric of space in the first fraction of a second, faster than light itself, smoothing the young universe into the vast, even canvas we still see. That is not a contradiction of the light speed limit, by the way, because it was space itself expanding, not anything moving through space. Then billions of years of stars living and dying, forging the carbon and oxygen and iron that make up you and me and presumably anything alive on Mars. Every atom in your body heavier than hydrogen was cooked inside a star that died before the sun was born. Think about that the next time you look at your own hand. It is furnace ash from ancient suns. The same physics everywhere. The same standard model of particles, that catalog of the basic building blocks and forces we have tested to astonishing precision in the Great Collider experiments, the same handful of forces running in every corner of the observable universe out to the cosmic horizon, the farthest edge from which light has had time to reach us. That uniformity is not an assumption. We read it in the cosmic microwave background, the faint afterglow of the Big Bang, glowing at almost exactly the same temperature in every direction we look, differing by only a few parts in 100,000 across the entire sky. The universe plays by one rule book, and that raises the question underneath all of this, the one that makes a bucket of Martian soil suddenly cosmic. If life started here, on one ordinary planet, around one ordinary star, from ordinary chemistry, then why not next door? Why not on the fourth rock, which was warm and wet and gentle for its first billion years, with rivers and lakes and maybe an ocean, back when life was already taking hold on Earth? The two worlds began the same experiment at nearly the same time, side by side, with similar ingredients. If one of them woke up, the fair question is why the other would not. And there is a shadow question hanging beside it, the one people call the Fermi paradox. If life is common, and the universe is old and enormous, where is everyone? Why is the sky so silent? Part of the answer may be the sheer physical cost of crossing light years of empty space, held back forever by the speed of light as a limit. but part of it may be that life itself is rarer or quieter than we hope. Mars is the nearest place to start testing which. There is also a puzzle physicists call the fine-tuning problem, the strange fact that the constants of nature seem set just so in a way that allows chemistry and stars and complexity to exist at all. Nudge a few of those numbers slightly and you get a universe with no atoms, no stars, nothing. Some people find in that a hint of a multiverse, countless universes with different settings, and we live in one that happens to work because we could not exist in one that didn't. That idea is contested, unproven, maybe untestable, and honest people say so plainly. It might be the deepest truth about reality, or it might be a story we tell because we have no way to check. Either way, our universe does allow life. It happened at least once. And if it happened once from nothing special, then Mars is the closest test we will ever get of whether it was a fluke or a rule. That is the real weight of these three little clues. They are not just about Mars. They are the nearest edge of the biggest question there is. Are we the exception or the example? And the answer might be buried a few meters down, waiting. So, let's bring it home. We started with an impossible-sounding claim that something may be alive right now beneath the surface of Mars. And instead of rushing to believe it or laugh at it, we did the harder and better thing. We asked how we could ever know. We faced the distance first. Tens of millions of miles, minutes of light lag, no human hand ever laid on that world. Everything we have is inference, a chain of reasoning from thin signals, where authority comes not from confidence, but from prediction and measurement. We learn to read light for the fingerprints of gases, those dark lines where a molecule stole its signature colors. We learn to check one instrument against another, to hunt the boring explanation before allowing the beautiful one to treat the dull theory as innocent until the thrilling one proves its case. Then we looked at three real findings. The methane, a fragile gas that vanishes fast, so any that is there must be freshly made by warm rock and water or by something breathing in the dark, rising and falling with the seasons like a slow tide, smelled by a rover on the ground yet nearly invisible to the orbiter above, which tells us it hugs the surface and seeps from specific spots. The old soil experiment, where Martian dirt seemed to metabolize a meal, breathed out tagged gas exactly as living things would, then broke our hearts by showing no molecules of life to do the metabolizing, teaching us that a dead planet can wear a living mask, that the same reading can come from microbes or from bleach-like salts, and we cannot yet tell which. And the radar, hinting at salty liquid water sealed beneath the polar ice in exactly the kind of place where, on Earth, life never fails to appear. If only we could be sure the water is truly there and not a trick of clay and cold. Each clue on its own dissolves under a boring explanation. That is the honest truth, and I want you to hold it firmly. But then we notice the thing that changes everything. All three point the same way. Down, away from the deadly surface, into the sheltered underground, where liquid water and steady warmth and shelter from radiation could still exist. Three independent instruments, three kinds of physics, one hidden address. And finally, we stepped back and saw why a puff of gas on another planet is really a question about the whole universe. The same Big Bang, the same physics, the same rule book everywhere we look, written into the even glow of the cosmic microwave background. Life happened here at least once. Mars is our nearest chance to learn whether that was a lonely accident or the ordinary behavior of a universe built, for reasons we do not understand, to allow it. That is the shape of what we know. A strong maybe, held to a high standard, pointing downward, echoing outward. Here is what remains genuinely, wonderfully open, and why that is exactly as it should be. We do not know if there is life beneath Mars. We really don't. Anyone who tells you flatly that there is, or flatly that there isn't, has stopped doing the reasoning and started guessing. Every clue we have carries a lifeless explanation right beside the living one. And from this distance, with these tools, we cannot yet choose. The methane could be rock chemistry. The breathing soil could be aggressive salts. The buried lake could be clay and ice. And that is not a disappointment. That is the frontier doing what a frontier does. To settle it, we may need to drill, to bring samples home, to hold a piece of Mars in a laboratory where every clever trick of dead chemistry can be tested and ruled out one at a time, where you can look for the one thing no dead process fakes well, the intricate structured molecules of living metabolism. There are deeper unknowns still, the ones no Mars mission will ever solve. We do not know what happened before the Big Bang, or whether that question even means anything. We do not know what lies inside the singularity at the heart of a black hole, past the event horizon where general relativity and quantum mechanics openly contradict each other and neither can be trusted alone. That contradiction is the great unhealed wound in physics. General relativity describes the huge and the heavy, the bending of space-time around stars, and it has passed every test we have thrown at it. Quantum mechanics describes the tiny, where a particle can hover in superposition, its wave function holding many possibilities at once until something measures it, and it too has passed every test. Both are astonishingly accurate. Both cannot be fully right as written. Push them together in the crushing center of a black hole or the first instant of the Big Bang, and the mathematics screams nonsense at you. We do not know if string theory, with its extra dimensions folded too small to see, is the repair that fixes that contradiction, or a beautiful idea we can never test. It is one attempted mend, not settled fact, and the honest position is to say so out loud. We do not know what dark matter is, the unseen mass that holds galaxies together, or dark energy, the force pushing the universe apart faster and faster, though together they make up most of everything. We do not even fully understand the arrow of time, why entropy only ever increases, why a broken cup never leaps back together, why the past feels fixed and the future open. And there are fresh surprises unsettling us right now. Deep observations of the early universe showing galaxies that look far more grown up, far sooner than our models expected. A quiet reminder that even our best story is unfinished. So much is unsettled, and I love that. Because a finished universe would be a closed book, and this one is still being read. Think about where you are standing on a warm, wet, unlikely world, made of atoms forged inside dead stars, gazing across tens of millions of miles at a cold red neighbor, and asking whether it too woke up, that we can even ask that question, and answer it with logic instead of legend, checking each link in the chain, ruling out the easy story before accepting the extraordinary one, is to me the most beautiful thing our species does. We took a few numbers beamed across the dark and turned them into an honest, careful maybe. We did not need to touch Mars to reason about its buried water. We did not need to visit the first instant of time to weigh what the afterglow of creation is telling us. We built understanding out of light and patience and the refusal to fool ourselves. The universe is under no obligation to make sense to us, and yet, piece by careful piece, it does. Somewhere out there, maybe a few meters beneath the Martian dust, an answer is waiting. We may reach it in your lifetime. And whichever way it falls, whether Mars is barren or quietly, stubbornly alive, we will have learned something enormous about how common the miracle of life really is, and about how alone or how accompanied we truly are. If exploring these questions gives you the same quiet thrill it gives me, I would love for you to subscribe and keep wandering this unfinished cosmos alongside us. Thank you for giving me your time and your curiosity today, truly, because there is no better company on a journey like this than a mind that still loves to wonder